Hi everyone, this is V. Srinivas, Assistant Professor in Mathematics, Mlritm. So I'm doing continuously videos on multiple integrals. So already I explained how to evaluate the double integrals in Cartesian form and double integrals in polar form. Today, in this today's section, I will explain about change of order of integration in double integrals. Change of order of integration in double integrals. So in generally in Cartesian form we have three cases: y in terms of x constants, or x in terms of y constants, and both are constants. So here y in terms of x is the constants. Here the students will have the doubt of why you are saying y in terms of x constant, why can't you say that x in terms of y and y constants? So if we change the given order of integration, then what will happen? So given integration is y in terms of x, that is y varies, x fixed. And if we change the order, that means x in terms of y and y constant, then what will happen? So we will see now what that is the change of order. So here even changing the variables, that is changing the limits, changing the order, the answer should be same. So before changing, whatever you got the answer, after changing also will get the same answer. But here whenever we change the limits, we change the order of integration, limits will change, even though answer should be same. So that is today's concept. I will explain this change of order with one example. So here sometimes, quite often, this change of order of integration is facilitates in double integrals. So in order to change the order, sometimes it is advisable, it is required to draw the rough sketch. It is advisable to draw a rough sketch, and from that we have to take the limits. Sometimes the region can be split into more number of integrals, and finally add all those integral values in order to get the value of the given integral. So first I will explain one problem, and then splitting of regions also I will explain another problem. The first question: change the order of integration and evaluate integral 0 to 4a integral x square by 4a to 2 root ax dy dx. That is the problem given. So how to evaluate this? So evaluate by changing the order of, don't evaluate directly, we have to change it. So as for the given problem, it's very clearly I is the given problem. I stands for integral. Let I is equal to integral 0 to 4a integral x square by 4a to 2 root ax. We know clearly this is y limits, x square by 4a to 2 root x is y limits, and x limits are 0 to 4a. Y, we know that y in terms of x constants, into dy dx, y in terms of x constants. First we have to describe the given integral in the view of limits. For fixed in this integral, for fixed x, in this integral, what is the status? For fixed x, in this integral, for fixed x, that means x constants, y varies from where to where? Y varies from x square by 4a to 2 root ax, and then x varies from, so and then x varies from 0 to 4a, This is the status of the given limits. Now after changing, what will happen, we'll see now. Before that we have to draw a rough sketch. So in order to draw a figure, we must know what is the region of integration. The region of integration for this problem, the region of integration is bounded by y is equal to x square by 4a to y is equal to x square by 4a means what? So it represents a one parabola. Y is equal to x square by 4a means that is x square is equal to 4ay. And what about upper limit? Y is equal to 2 root x. What it represents? Y is equal to 2 root x. Squaring on both sides, that is y square is equal to 4x. That means our region of integration is bounded by two parabolas, x square is equal to 4ay and y square is equal to 4ax. So now we have to draw the figure which represents region of integration. So here in this figure, it's very clear to say that it is bounded by two parabolas. So x-axis and y-axis. We know how to draw the two parabolas, that is x square is equal to 4ay. We know and y square is equal to 4x. If x has the even powers, that means x square is the even power. X has the even powers, we should draw the parabola in y direction. Y has the even powers, draw in x direction. Y direction is nothing but vertical. X direction is nothing but horizontal. So first one, x square is equal to 4ay. X square, x even terms, that's what I am drawing. Y direction, that is vertical. That is x square is equal to 4ay. Then y square is equal to 4x. Y square, that means y has the even power. So we should draw in x direction. That means horizontally. This is this is x square is equal to 4ay, and this is y square is y square is equal to 4ax, and this is x square is equal to 4ay. Now in this region, this is a region. In this region we have to integrate. It's very clearly say that this is the origin 0, 0. And this is the point of intersection, OA, point of intersection. What is the point of intersection of y square is equal to 4ax and x square is equal to 4ay? It's very clear. So the values of x and y which satisfies x square is equal to 4ay and y square is equal to 4ax. The simple option is 4a, 4a. 4a whole square is equal to 4a into 4a. So that's what here 4a, 4a is the point of intersection of these two parabolas. In this region we have to integrate now. So as for the given problem, from the limits of the given problem, which is varies, which is fixed, already we wrote here y varies, x fixed. Y varies means y means always vertical strip, x means horizontal strip. So here y varies, this is the vertical strip, y varies. So after changing the order, before changing it is vertical because y varies. After changing the order, the strip becomes horizontal. The strip becomes horizontal. So after changing the order. So anyhow, before changing it is a vertical strip, that means y varies. After changing it is a horizontal strip, that means x varies. So after changing, what are the new limits? First we have to find. So here from this horizontal strip, what are the limits of x and the limits of y? It's very clear to say that. So x, one edge is on this parabola, another edge is on this parabola. So one edge is on the parabola y square is equal to 4ax. That means what is x? X is equal to y square by 4a. It's very clear to say that x is equal to y square by 4a. This is lower limit. And coming to the upper limit, this is lies on the parabola x square is equal to 4ay. X square is equal to 4ay means what is x? X is equal to root 4ay. Root 4ay means 2 root ay. These are the x limits. Now x is variable limits. X varies. And then y. Y should be constant. Then what are the y limits? y limits are, so y coordinates 0 to 4a. Y limits are 0 to 4a. These are the new limits after changing the order. Before changing y varies, after changing x varies. That means before changing y have the variable limits in terms of x and x constants. After changing x has the variable limits in terms of y and y is constants. So so therefore I is equal to, so after changing, on changing the order of integration, we have on changing the order of integration, on changing the order of integration, which is fixed before changing y variable limits, x constant limits. Now after changing x variable limits, y fixed. For fixed y, that means y limits are constants. For fixed y, x varies from where to where? X varies from, so here it's very clear, x varies from y square by 4a to y square by 4a to 2 root ay, and then y varies from, y fixed, y constant, and then y varies from 0 to 4a. These are the new limits after changing the order of integration. Therefore, the given integral I is equal to, just I am writing what is the before changing, y is equal to y, so y is equal to x square by 4a to x square by 4a to 2 root ax, and x limits, x is equal to 0 to 4a dy dx. This is before changing. Now after changing, what are the new limits from the region of integration? X varies from y square by 4a to 2 root ay, and y varies from 0 to 4a dx dy. Now let us start for integration. First with respect to x, keeping y terms constant, and then with respect to y, then we get the integral value. So first with respect to x, integral of 1 dx, it's very clear to say that integral of 1 dx, is x, 0 to 4a, integral of 1 dx is x, within the limits y square by 4a to 2 root ay, within the limits y square by 4a to 2 root ay dy. Now we have to apply limits, that means upper limit minus lower limit. Integral 0 to 4a upper limit, in place of x what I have to substitute? 2 root ay minus y square by 4a, upper minus lower limits, into dy. Now we have to split the terms. So 2 root ay, how to write? Root a into root y. 2 root a is constant, integral 0 to 4a root y dy, minus, so here also 1 by 4a is constant, integral 0 to 4a y square dy. So first term is 2 root a into root means power 1 by 2. So y power n formula, y power n is equal to y power, integral of y power n is y power n plus 1 by n plus 1. That means y power 1 by 2, because root means 1 by 2. 1 by 2 plus 1 by 2. So y power 1 by 2 plus 1 by 2 plus 1, limits 0 to 4a, minus 1 by 4a into integral of y square dy, y cube by 3. Y cube by 3, limits 0 to 4a. So now as usually apply the limits upper minus lower. 2 root ay into upper limit. So upper, that is 4a, in place of y we have to substitute 4a. 4a power 3 by 2 by 3 by 2, minus 1 by 4a into, so here lower limit is 0, that's what leave it. And coming to the second term, what is upper limit? 4a. In place of y, we have to substitute 4a. 4a whole cube by 3 minus 0. So here 1 by 3 by 2 becomes 2 by 3. Already 2 is there in the numerator. 2 2s are 4. 4 that is equal to 4 into root a by 3. And 4 power 3 by 2 into a power 3 by 2. Minus 1 by 4 into 3, 12. 1 by 12 a into 4a whole cube. 4 cube into a cube. 4 cube means 64. 64 into a cube. So here this a in a square 2 times cancel, and in 12 4 3 times cancel, in 64 4 16 times cancel. Coming to the first term, in the first term 4 power 3 by 2. 4 power 3 by 2 is nothing but 4 into root 4. So that is root 4 means 2. So 4 into 2, 8. That means 4 power 3 by 2 is nothing but 8. So 8, already 4 is there. 4 into 8, 32. 32 by 3 into root a into a power 3 by 2. Root a is nothing but a power 1 by 2. A power 1 by 2 into a power 3 by 2. We know bases are equal, power should be added. A power 1 by 2 plus 3 by 2, that is 4 by 2. 4 by 2 means 2, a square. Minus, already here after cancellation, 16 by 3 a square. So here 32 minus 16, 16 by 3 a square is the answer. So it's very clear to evaluate the double integral by changing the order of integration. So before changing, y varies and x constant. Y varies means y variable limits, x constant limits. After changing the order of integration with proper diagram, so x varies and y fixed. So that's what first we have to integrate with respect to x, whatever the y terms keeping constant, but in this problem there is no y terms. Integrate with respect to x keeping y terms constant, and then integrate with respect to y within the given limits. Finally we get the answer, that is 16 by 3 into a square. So in this problem one similarity everyone have to identify. So these both are parabolas. The region is bounded by in two parabolas only. Suppose one is parabola, one is line. So other means two different things are there, then how to evaluate the problem? This problem is between two parabolas. Region is bounded between two parabolas. That's what here we can get easily without splitting the region of integration. Suppose some problems we require to split up the region into number of parts and then add all the integral values. That type of problem we will discuss now. So here I hope this problem understood very well. Now next sum. Change the order of integration. Next question is, by changing the order of integration, we have to evaluate. What is that integral? Integral 0 to 1, integral x squared to 2 minus x, xy dx dy. So what is the given integral? Let I is equal to, I stands for given integral, integral 0 to 1, integral x squared to 2 minus x, xy dx dy. Dx dy. First, the important thing is identification of limits. The student must make the capacity of identifying the limits. So they able to build up the capacity of identifying the limits. Once they identify the limits, then we can solve easily. So here always remember y in terms of x or x in terms of y. Don't write x in terms of x only, y in terms of y only. So that's what here, this x squared to 2 minus x, obviously y limits. So one is y limit, automatically rest of one is x limits. So that's what here we have to write the limits clearly. Y limits are x squared to 2 minus x. And x limits are 0 to 1. This is the identification of limits. X, y. So here y limits first. That's what, write dy first. Whatever the given order, we have to arrange in a correct order. Dy and then dx. This is the given integral. From this integral, we have to write the status. From this integral, what are the fixed limits? What are the variable limits? from this integral for fixed x fixed, for fixed x, y varies from, for fixed x, y varies from where to where, x square to 2 minus x, square to 2 minus x, and then x varies from, 0 to 1, x fixed limits, constant limits, y variable limits. Right. This is the given problem status. That means the given problem with limits. Now we need to change the order and then evaluate. Not direct evaluation. We can do direct evaluation, but here particularly it is mentioned change of order of integration. So in this video I am explaining when change the order what will happen. So without changing already we did. So here 0 to 1. Now it's very clear to say that what is the region of integration. The region of integration that depends on limits only. The region of integration is bounded by, what are the limits? Bounded by y is equal to x square and y is equal to 2 minus x. So here tell me y is equal to x square represents what? It's a parabola. Y is equal to 2 minus x represents, it's a line. Y is equal to 2 minus x is nothing but x plus y is equal to 2. So the region of integration is bounded by one parabola, x square is equal to y, one line, x plus y is equal to 2. Now we should draw the rough sketch. From that we can get the new limits after changing the order. So before changing the order, as per the given limits, the region is bounded by one parabola and one straight line. So we know how to draw the figure. So x square is equal to y, x even powers. X even powers means we have to draw the parabola in y direction, that means vertical. This is x square is equal to y. Then line, given one more line. What is the line? X plus y is equal to 2. X plus y is equal to 2 is the line joining the points 0, 2, 2, 0. So first how to say that this line, where we have to draw this line, that depends on the point of intersection. It's very clear. So this is x axis, means y is equal to 0. Y axis, that means x is equal to 0. This is x is equal to 0. Yeah, simply substitute y is equal to 0 here. X plus y is equal to 2, y is equal to 0 means x is equal to 2. That means the point of intersection is 2, 0. So the point on the x-axis is 2, 0. Next, whenever on the y-axis, that means if we substitute x is equal to 0, y is equal to 2, that means the point is 0, 2. The point is 0, 2. So when we join these 2 points, we get the point, we get the line. Which line? This line represents what? X plus y is equal to 2. This is the parabola, y is equal to x square. Now in this region we have to integrate. So look at this region. This region is bounded by first point O, 0, 0 origin, and this is the point of intersection of one parabola and one line. So what is this point of intersection? So generally point of intersection means by solving 2 we will get the answer. That means just substitute y is equal to x square in x plus y is equal to 2. So x plus y is equal to 2, I am substituting y is equal to x square, that is x plus x square is equal to 2. That means x square plus x minus 2 is equal to 0. When we find the roots of this, that is 1, minus 2. But our region is in the first quadrant, so 1 only correct, minus 2 is not take, don't take minus 2 here. So that means x value is 1. As for this point of intersection, x value is 1. Then what about y value? Substitute x is equal to 1 here, y is equal to x square, that is 1 square, 1 only. So the point of intersection is 1 comma 1. So this is the way of finding point of intersection by solving the given line and parabola. Without solving also, we can easily say that the point of intersection. The simple thing tell me here, x plus y is equal to 2, y is equal to x square. That means two numbers sum should be 2, one number square is the another number. So it's very easy. 1 plus 1 is equal to 2, 1 square is equal to 1. That means point of intersection is 1 comma 1. Without solving this also, we can easily say that the simple mathematical technique. So x plus y is equal to 2, 1 plus 1 is equal to 2, and 1 is equal to 1 square. 2 plus 0 also 2, but not 2 is equal to 0 square and 0 is equal to 2 square. So the option is 1 comma 1. So right, this is 1 comma 1. So if I draw the line which is exactly middle, then this point becomes, this is B, this point becomes, this is 1, it's very clearly, on y-axis 0, 0 comma 1. So the point O is 0 comma 0, A is point of intersection 1 comma 1. If I draw the line in the middle of the region, we got the point which touches on the y-axis is 0 comma 1, and this is 0 comma 2 is the point C. So now entire region is OACBO. This is the entire region. Now this region, why I am drawing here middle line? So here the region can be divided into two parts. So in the last problem, there is no such type of problem. In the last problem, we can't draw any line and it can't be divided into two parts. Why in this problem the area is divided into two parts? That's the important thing. Where we have to take the division of the areas, where we can't take the division of areas. Well, coming to the last problem. So here, coming to last problem. In this problem, so if it is from this side to this side, here any manner is a uniform region. That means one edge is on one parabola, second edge is on one parabola, and second edge is on another parabola. Anyhow, the two edges must be lies on the parabolas only. There is no change. So that's what here the area can't be divided into two regions. While coming to this problem, in this problem, that's very important and sensitive point is, so if we take first half, that means OAB, in the region OAB. So we will take one horizontal strip. In this horizontal strip, one edge is on y-axis. That means x is equal to 0. And another edge is on parabola. That means y is equal to x square. Parabola y is equal to x square. Understood? Now, in OAB, particularly half of the region, in OAB, if we take the horizontal strip, why are taking horizontal strip? So here already I said y varies means vertical strip, x varies means horizontal strip. As for the given limits, y varies. Y varies means as per the given problem, this is the vertical strip. So this sliding is like this only, sliding like this. That means uniformly sliding. The sliding is going on uniform manner. As for the vertical sliding, that means from the given problem. After changing, this vertical sliding becomes horizontal. After changing, vertical strip becomes horizontal. So in this horizontal strip, for the horizontal strip, so in the first half, that is OAB, one edge is on which axis? One edge is on y-axis, another edge is on parabola. While after reaching the middle of the region, that means after the in the region of ABC, if we take horizontal strip, what will happen? We'll see very clearly. So one edge is on y-axis. That means first edge is on y-axis. That's okay. And coming to the another edge, it's not in the parabola. It is on the line. You got everyone here. This is very simple. This is one of the important identification. So in the lower region, that means OAB, one edge is on y-axis, another edge is on parabola. So after first half, that means in the second half, ABC or ACB. In this, one edge is on y-axis, another edge is on the line. That means the strip which is on parabola will become on line. So that's what, it's not a uniform. That's what we divide the given region into two parts. In the last question, there is no, it's never happens because both are parabolas. If we take anywhere, that means in that region, anywhere we can take one edge is on parabola, another edge is also on parabola. But here, in half of the part, for lower half, one edge is on parabola and upper half, that edge is on line. That's what we require to find the integral value in OAB and integral value on ABC and then add the integrals. So this is the another concept of change of order of integration. We require to split up the region, entire region into parts and then add the integral values. So here along OAB from the figure, on changing the order of integration, on changing the order of integration, on changing the order of integration, the entire region can be split into. So that is the region of integration is represented by horizontal strip, represented by horizontal strip, and the entire region and the region of integration, Ri, region of integration, can be split up into two regions, split up into OAB and ABC, split up into two regions, OAB and ABC. So therefore the given integral I, integral 0 to 1 integral x square to 2 minus x, integral x square to 2 minus x, xy dy dx. This is from given integral. This is y limits, this is x limits, is equal to, after changing, it can be divided into two regions, OAB, double integral over OAB xy dx dy plus double integral over ABC xy dx dy. Integrand is same. So now we have to find the new limits. Along OAB, coming to the diagram, this diagram is very, very important. Along OAB, what are the new limits? So here OAB, if we take OAB, already explained, as per the horizontal strip, one edge is on y-axis. That means x is equal to 0 is the lower limit. And another edge is on parabola, y is equal to x square. Y is equal to x square means x is equal to root y. Now we are writing x in terms of y because it's a horizontal strip. X varies, x variable limits. So here, that's what here, x limits are from 0 to root y. And then, so here for fixed, here before changing, x fixed, y varies. Now after changing, any manner, that is in OAB or ABC, in any region, the logic is same. X varies, y fixed. For fixed y, x varies from, from the figure already explained, x varies from 0 to root y. So here very clear from the figure, 0 to, because on y axis, and y is equal to x square means x is equal to root y. And then y varies from, y varies from where to where? From the figure only. Y means vertical. So here y limits 0 to 1. Otherwise 0 to 1. Here 0 to 1 y limits. We can take like this also 0 to 1 in the region OAB. So in the region OAB, what are the y limits? Y limits from 0 to 1. This is about OAB. And what about next region? Along ABC or ACB, any manner, no problem. Along ABC. Coming to the diagram, here also y is fixed, x is varies. First x variable limits and then y fixed. For fixed y, x varies from, for fixed y, x varies from, 0 to, because lower strip, that is, if we take this strip, the edge is, lower edge is on y axis only, x is equal to 0. But another edge is on the line, x plus y is equal to 2. X plus y is equal to 2 means what is x? 2 minus y. X plus y is equal to 2. Now we want x in terms of y. X is equal to 2 minus y. That is the upper limit of x. X varies from 2 minus y. And then y varies from, already I said y means vertical. Now look at this, y varies from 1 to 2, otherwise from this to this, 1 to 2. Y varies from 1 to 2. It's very clear from the figure. So here, in order to do this type of problems, the student must have the basic knowledge of geometry. So here 1 to 2 are, so if we take B to C also 1 to 2 and A to C also 1 to 2. In the region ABC, the y limits are 1 to 2. So here y varies from 1 to 2. Therefore, I is equal to, given integral I is equal to, so what are the limits along OAB? X limits are 0 to root y limits are 0 to 1. Xy dx dy plus, this is only OAB, plus what about ABC limits in the region ABC? So x limits are 0 to 2 minus y and y limits are 0 to 1 to 2. Xy dx dy. Now we have to evaluate these two parts. By adding these two parts, we get the answer. Already I wrote plus. So that's what we'll do separately. Otherwise, simultaneously, we can compute both. We can evaluate both integrals. So here I'm doing simultaneously. So integral 0 to 1. First with respect to x. In the both integrals, first we have to integrate with respect to x, keeping y terms fixed. We know rules for integration. In my previous video, I clearly explained how to take limits, that is how to integrate when both x in terms of y and y constant, y in terms of x and x constants. So first here we have to integrate with respect to x, keeping y terms fixed. So y constant, integral of x dx. Integral of x dx is x square by 2 within the limits 0 to root y dy. This is about first integral. And coming to the second integral, in the same manner, y limits 1 to 2. First we have to integrate with respect to x, keeping y terms constant. Y constant, integral of x dx is x square by 2, limits 0 to 2 minus y dy. Then we substitute the limits, upper minus lower limits. So that means in place of x, we have to substitute the limits. So I is equal to integral 0 to 1 y, 0 to 1 y into x square by 2. In place of x, what we have to substitute? Root y whole square by 2. That means root y whole square means y by 2. So here root y whole square by 2. Simply in place of x, I substitute root y. Lower limit is 0 by 2, 0 only, into dy. This is first integral. Coming to the second integral, y limits 1 to 2, y into, in place of x, 2 minus y whole square by 2. Lower limit 0 into dy. So in place of x, what we have to substitute? 2 minus y. X square is there. That's what 2 minus y whole square by 2 into dy. So now we can simplify this. Integral 0 to 1 root y whole square means y. Y into y square by 2 dy. That is the first term. Plus second term, this is y 1 by 2 constant right outside. Integral 1 to 2. Integral 1 to 2. So y into 2 minus y whole square. Expand 2 minus y whole square. A minus b whole square formula. A square, that is 2 square 4, plus b square, that means y square, minus 2ab. 2 into y, 4y into dy. So that is equal to, here also 1 by 2 constant right outside. Integral of y square dy is y cube by 3. Limits 0 to 1. That is the first term. Plus coming to the second term, 1 by 2 into integral 1 to 2. So y, 4 into y, 4y, plus y into y square, y cube, minus 4y into y, 4y square dy. So here in the first term, I have to substitute. We have to substitute the limits. So that is 1 by 2 into upper limit 1, 1 cube by 3, 1 by 3, lower limit 0. Plus 1 by 2 into, now we can apply the integration, y power n formula. We know that y power n is y power n plus 1 by n plus 1. So that is 4 into integral of y dy. What is integral of y dy? Integral of y dy is y square by 2. Plus integral of y cube. Integral of y cube is y power 4 by 4. Minus 4 into integral of y square is y cube by 3. Within the limits 1 to 2. Now we need to apply the limits. So that is 1 by 2 into 1 by 3, 1 by 6. Plus 1 by 2 into, here when I apply the upper limit first, that is 4 into, so 2 square by 2, plus 2 power 4 by 4, minus 4 into 2 cube by 3. So this is only upper limit. Minus, when I apply the lower limit, that means in place of y, we have to substitute 1. So 4 into 1 cube by 2, that is 4 into 1 by 2, plus 1 power 4 is 1 by 4, minus 4 into 1 cube, 1 by 3. This is the lower limit. So that is equal to, first term is 1 by 6, plus second term 1 by 2 into, now simplify this. This 2 into square 2 times cancel, 4 2s are 8, plus 2 power 4 is 16, 16 by 4 is 4, minus 2 cube is 8, 4 8s are 32, 32 by 3. This is the first term. Minus, this is 2 in 4 2 times, plus 1 by 4, minus 4 by 3. That is lower limit. So that is equal to 1 by 6 plus 1 by 2 into 8 plus 4, 12, 12 minus 32 by 3. If I take LCM, if I take the LCM as 3, 12, 8 plus 4, 12, 12 into 3, 36, 36 minus 32. Minus, what about second term? Here also, if we take 3 is LCM, 3 2s are 6, this is by 1, 6 plus, and 12 is LCM, because 4 also there, 4 to 3, 12 LCM. So that means 12 LCM means 2 12s are 24 first term, and 3 times plus 3, and this is 4 times minus 16. 4 4s are 16. So whole bracket. So that is equal to 1 by 6 plus 1 by 2 into 36 minus 32, 4 by 3. This is the first term, 4 by 3, minus. So here 24 plus 3, 27, 27 minus 16, 27 minus 16. So that is equal to 11, 11 by 12. 11 by 12. So that is equal to 1 by 6 plus 1 by 2 into, it's very clear, 1 by 2 into. So here, what should I take again? LCM is 12. 12, this is 4 times cancel, 4 4s are 16, 16 minus 11. So that is equal to 1 by 6 plus 1 by 2 into 16 minus 11, that is 5 by 12. So that is equal to 1 by 6 plus 5 by 2 12s are 24. Again 24 is the LCM, So that is 6 4 times cancel, 4 plus 5 9, 9 by 24. 9 by 24 means 3 in 9 3 times cancel, in 24 8 times cancel. The final answer is 3 by 8. This is the way of evaluating integrals. This mathematical part anyone can do easily. The important thing is how to identify the limits after changing the order of integration. Before changing the order of integration, what are the limits? After changing the order of integration, what are the limits? Before changing, we have to identify what are the y limits and what are the x limits. After changing, so sometimes it can be split into two regions, sometimes uniform region. I explained two types of problems. The first question, that is in the first problem, no need to split into regions. But whereas in the second question, the current problem, we need to split into regions. So anyhow, final answer is same. So here, this is a way of doing or evaluating double integrals when we change the order of integration. I hope everyone understood easily. This is a easy concept I introduced. So here, I hope you understood better. Thank you to everyone.